Our next speaker is Patel of NIEHS, and his talk is entitled Update, the Intersection Between Policy-Based Data Management and Emerging Health Science Data Standards.
Hey, I'm Patel from National Institute of Environmental Health Science. Mike Conway is my colleague who has prepared this presentation. We are part of NIH that deals with environmental exposures and human health. Today, I'm going to present on our use of iRods and how we think iRods fits into the data ecosystem across NIH. NIEHS has run iRods for several years. It is the main repository of our epigenomics data. We have a pipeline that takes data from our sequencing lab, gathering information from multiple sources, including Clarity LIMS, our project and some sample submission systems, and from instruments themselves. We use flow on Slurm to pre-process and run QC before depositing data in our commons. We record all of the relevant metadata and make it available for search. Our epigenomics data is growing all the time. To date, we have processed almost 2,000 runs. We are in the planning process to begin to add special transcriptomatics data to commons now. We offer metlinks to our bioinformatics and epigenomics researchers and have built a search plugin system that creates multiple custom indexes and search interfaces to projects and samples. Currently, we are working on a project called CODES. This is funding under PCOR, or Patient-Centered Outcome Research. It looks at the intersection of climate change and public health. This project is using open source Gen3 platform to create a data catalog. We are collaborating with the University of Chicago and the Biomedical Research Hub. The CODES catalog is seen as an entry point to an environmental health data ecosystem. This is outward facing and meant to catalog data that exists across institutions and governmental entities. Our iRods-based commons is internally facing and has been very successful. CODES and Gen3 are tackling an entirely different set of problems around data sharing with external world. CODES is important to us as we begin to tackle ways to bring exposure data into human health. Linking NIEHS data to broader NIH and beyond will be a major focus for us in the Office of Data Science. We progress on this front. We observe that emerging trans-NIH data ecosystem is based on federation. Federation has been at the core of iRods since the beginning, but this notion of federation has evolved in some respects. The biggest differentiator with the new notion of federation is that ecosystem is designed to be heterogeneous. This means that the exact specification of federation mechanism changes mostly to be more lightweight, but the underlying capabilities of a node remains largely the same. The policy-based data management capabilities of iRods and the maturity of the technology can be great strength in the emerging data ecosystem. The talk today is really focused on this observation and suggests ways to bring our notion of iRods capability into these new areas. The iRods consortium early on organized how they describe the platform in terms of capabilities. At the core, from the way back in the DICE era, was this notion of policy-based management of data. This stemmed originally from an emphasis on digital preservation and archiving. Our argument here is that this core policy management principles apply no more than ever. We just need to talk about them a bit differently. iRods went through an era where the focus was on abstraction of storage, especially new ways of organizing resources and plugging in cloud data sources. NIH is moving rapidly to the cloud, as are many other organizations, and many of the new approaches to data sharing are focused on the cloud. iRod sits in an unique spot because it can be a platform that bridges on-prem and cloud data, filling what amounts to a blind spot in how we think about data collaboration. We talk in a bit about this notion of federated analysis, the ability to run workflows and workspaces that span organizations and cloud platforms. Federated analysis is a primary focal point of NIH. As the old saying goes, everything old is new again. Keep this notion of iRod's compute to data in mind. For those of you familiar with the way iRod used to talk about federation, for example, in the DataNet days, you may find a lot that is familiar in this new fashion discussion of data mesh. Data mesh are meant to be connected through lightweight standards and interfaces, especially since the intent is to connect heterogeneous nodes. Making iRods operate in a data mesh is thus more problem of interface rather than an issue about capability. Data meshes are decentralized where each node owns their own data, typically data for a specific domain. The data is the focus, and the mesh architecture is about supporting a data discovery, data access, and distributed analysis workflow. This is a self-serve model where researchers identify and link together data of interest and bring their own workflows and tools to the data. Data governance thus fits nicely in iROS policy model, where each remote node can enforce their own management policies underneath the mesh. So how do we bring the capabilities of iRods in this world of data meshes? iRods already does all the things. That's the good news. The data mesh concept focuses on lightweight interfaces, but also imply many capabilities that are already close to the picture we already have. iRods is really good at metadata management, supporting query, indexing, and search, abstracting data no matter the underlying data storage mechanism, applying policies to manage authorization, providing foundational support for compute to data, though there would probably some significant development here. So we have the capabilities. Would need to adopt this data mesh concept of federation and more importantly, adjust the way we talk about iRods capabilities. A lot of this stuff iRods already does well. A good deal of data mesh conversation, especially the important data mesh capabilities for federated analysis, are already taking place in GA4GH. This is the Global Alliance for Genomics and Health. Several work streams taken together overlap very well with how people are talking about data meshes, especially across NIH. Typical of this is a recent announcement of a new strategic collaboration meant to enhance NIH's voice in GA4GH standards and to better promote these standards within NIH. If you join any of the work streams, you will see folks from all over NIH participating. So let's look at some of the work streams, how they play in the capabilities of data mesh, and how iRods may fit in. A big concern is data discovery, searching, and finding cohorts and data sets across federated data. Related to this is the need to bring different structured data sets together from different sources. For both of these cases, Data Connect workstream is relevant. It consists of a definition of an underlying data set defined as JSON schema, a method for writing query based on this schema, an API for handling queries, and access to tabular data. There are two ways iRods could work with Data Connect. The first would be to allow iRods metadata through jQuery to be surfaced through Data Connect API. The second way iRods can leverage Data Connect would be to expose structured and tabular data contained in iRods data object via Data Connect. Unlocking that would be otherwise opaque. Data Connect and efforts to develop approach to federated search across distributed data is a major concern at NIH. Now that we can discover data sets on data mesh, we need to be able to get all the bits to do interesting things. And by interesting things, we mean run analysis tools and workspaces. The point of DRS, the data repository service, is to present data stored in some location using an opaque handle, and to provide well-known access methods based on authentication for data sets, along with information on the location of that data. This references masks the underlying storage and can be used as references in a workflow or other analysis tools. It goes without saying that IROS is pretty good at abstracting data location and presenting an uniform access mechanism. IROS can apply policy and is aware of actual location of dataset. Uniquely, IROS can operate on on-prem data as well as cloud data. IRODS is built at its core to enforce data management policies, including rule engine and a system of policy enforcement points and a facility to maintain policy-related information as metadata, regardless of the access method or client. GA4GH has a workstream that is developing a notion of data passport. Data passport contains a set of visas that indicate the role and the access of a person. This can include encoding decisions of data access committees or other authorities granted to user to access specific data sets. There is a system of brokers and clearing houses that participate in the issuance and granting of access rights. The areas where policy management intersects with passport and new security model in federation is a bit tricky, but worth attention. Recall that we brought up a slide on IROS capabilities that focused on compute to data. The standards that we have been talking about and ideas about data meshes are focused on the notion of federated analysis. The general notion is that as a researcher, I can define a workflow standard language, such as CWL, WDL, or Nextflow. These workflows are run by an implementation of work execution service or WES. A workflow is composed of tasks. These tasks are dispatched by WES to a task runner at some location that supports test standard. The task run at remote location where the data resides and access the underlying data via DRS references. We have tried to walk through how many different existing IROS capability fit nicely into this federated analysis pattern. And that is the whole theme of this talk. IROS is a mature system. In fact, it is more mature than many of the cloud-based solutions in some respects. The theme of storage, abstraction, federation, and policy-based data management have been changed dramatically. What is different is the view of federation via lightweight data mesh approaches in terms of standards and API that are applied. Thank you. That was the presentation. Thank you.
Do we got any questions for Deep? Any questions? We got a question all the way in the back.
Did you face any issues while integrating Nextflow and IROTS?
No, so we are running Nextflow with Slum. So the only thing we have to keep into consideration was how we mount the volumes and the storage. And apart from that, it worked pretty nicely with the service account of IRODS and iCommands, as everything is Dockerized in Nextflow.
Thank you.
Any other questions? All right. Thank you, Deep.
Thank you.